Hello and welcome back to Chopstick Maths. To find the particular integral pi when capital X is cos ax or capital X is sin ax. Now consider this differential equation, this general form of differential equation, f of d into y is equal to capital X. The particular integral of this differential equation pi will be 1 upon f of d into capital X. Now, when capital X is cos ax or sin ax, so let us find out what will be the particular integral. Now, consider this differential equation, d into y is cos 3x. Now, this is of the type f of d into y is equal to capital X, where f of d is d and capital X is cos 3x. So, the particular integral of this differential equation will be equal to pi is 1 upon d into cos 3x. Now, as we know, d is the differential operator, so 1 upon d will be the integral. So, pi would be equal to integral of cos 3x dx. So, pi is equal to integral of cos 3x is sin 3x upon 3. Now, consider the second case when f of d is a function of d square, that is when f of d is phi of d square. Then, the particular integral will be 1 upon phi of d square into sin ax. Now here you will have to substitute d square as minus a square. So the particular integral will be 1 upon phi of minus a square into sin ax, provided phi of minus a square is not equal to 0. Now based on this, let us consider one example. The given differential equation is d square plus 4 into y is sin 3x. Now, if you compare with this, f of d is d square plus 4 and capital X is sin 3x. Now, we see that f of d is a function of d square. That is phi of d square is equal to d square plus 4. So, the particular integral will be 1 upon d square plus 4 into sin 3x. Now, since f of d is a function of d square, that is f of d is phi of d square, we'll have to substitute d square is minus a square and a here is 3. So, pi will be equal to 1 upon minus 3 square plus 4 into sin 3x. Therefore, pi is 1 upon minus 9 plus 4 into sin 3x. Therefore, pi is equal to 1 upon minus 5 into sin 3x. Now, here we can see that phi of minus a square is not equal to 0. Therefore, the pi is 1 upon minus 5 sin 3x. Now, consider this differential equation. D plus 3 into y is cos 2x. Now, f of d here is d plus 3. So, the particular integral is 1 upon d plus 3 into cos 2x. Now, here what you do is, you multiply and divide this by d minus 3. So, pi would be equal to d minus 3 upon d plus 3 into d minus 3 into cos 2x. Now, if this was d minus 3, then you had to multiply and divide by d plus 3. That is, whatever is the factor here, you multiply and divide it by the opposite factor. So, pi will be equal to d minus 3 upon product of this is d square minus 9 into cos 2x. Now you see over here, this is a function of d square. That is phi of d square is d square minus 9. Therefore, substitute d square is minus a square. A here is 2. Therefore, d square is equal to minus 2 square. So, the particular integral will be d minus 3 upon d square we have substituted as minus 2 square. So, this would be d minus 3 upon minus 2 square minus 9 into cos 2x. Therefore, pi would be equal to d into cos 2x minus 3 into cos 2x upon minus 13. Therefore, pi will be equal to, now d is the differential operator. So, d of cos 2x, here is the formula, d dx of cos of f of x is minus sin f of x into d dx of f of x. Therefore, d of cos 2x is minus sin 2x into derivative of 2x, that is 2 minus 3 cos 2x upon minus 13. Therefore, pi is equal to, taking the negative side outside, minus into bracket 2 sin 2x plus 3 cos 2x upon minus 13. Here the negative sign cancels, so pi is equal to 2 sin 2x plus 3 cos 2x upon 13. Finding the particular integral when capital X is cos ax or capital X is equal to sin ax. Consider the general form of the differential equation f of d into y is equal to capital X. Now, the particular integral of this general form of differential equation will be equal to 1 upon f of d into capital X. So, consider this given differential equation d square plus 4 into y is cos 2x. Now, here if you see f of d is d square plus 4 and x is equal to cos 2x. Therefore, the pi would be equal to 1 upon d square plus 4 into cos 2x. Now, here if you see f of d is a function of d square, that is f of d is phi of d square, which is equal to d square plus 4. So, here you will have to substitute d square as minus 2 square. So, pi would be equal to 1 upon minus 2 square plus 4 into cos 2x. That is, pi is equal to minus 2 square plus 4 is equal to 0. So, pi is 1 upon 0 into cos 2x. Now, here we cannot apply, as the denominator has become 0, we cannot apply this particular property. So, now we will consider using this property. That is, if f of d into y is equal to cos ax, then pi is 1 upon f of d into cos ax. Now, if f of d is a function of d square, that is, f of d is equal to phi of d square, then pi will be equal to 1 upon phi of d square into cos ax. Now, here we'll have to substitute d square is equal to minus a square. So, pi will be equal to 1 upon phi of minus a square into cos ax. But if phi of minus a square is equal to 0, then we'll have to use this property. Pi will be equal to x cos ax upon phi prime of d square. So, pi will be equal to x cos ax upon phi prime of d square. That is, we'll have to take the derivative of phi of d square. Now, here if you see, phi of d square is d square plus 4. Phi of d square is equal to d square plus 4. Therefore, phi prime d square, derivative of d square plus 4, derivative of d square is 2d and 4 is 0. So, phi prime d square is equal to 2d. So, the pi, as per this property, pi would be equal to 1 upon 2d into x cos 2x. So, pi will be equal to x upon 2 into 1 upon d cos 2x. Now, as you know, 1 upon d is the integral. So, pi is x upon 2 integral cos 2x dx. So, pi will be equal to x upon 2 integral of cos 2x dx is sin 2x upon 2. Therefore, the pi is x sin 2x upon 4. Thank you very much.